Hello everyone, it's NetworkBret. I'm getting further into the IPv6. Going to explain it to everyone, help me understand it better by explaining it, just understanding it at a deeper level and being able to explain it rather than just understanding it. So, three types of addressing or addresses in IPv6: unicast, multicast, anycast. IPv6 does not use broadcast addresses anymore, like IPv4 did. That really caused a lot of problems. Uh, it doesn't seem like the best plan to just send your traffic out to everywhere. So they do it different, and I'm gonna go over some of these today. It's kind of long, just the notation, explanation, and some of this stuff is it takes a while. So I'll do some of it today. Different rules is the interface can have multiple IPv6 addresses of any type. So they could have more than one unicast, more than one multicast, anycast, and you can reference that interface by any of those. So, if one matches, you don't have to list everyone as long as one matches. IPv6 addresses have a scope of global or local, explained later. And the notation of IPv6 is in hexadecimal. So denary is just what you're used to, what numbers are. The binary is what the hex represents. So this is a little bit confusing, but just know if the hex is showing a 1, it's not actually a 1. It's this binary example because IPv6 is 128 bits. So it's you might only see, what is it, 32 or whatever, but it's because each one represents 4. So even though you might see these, they're not as simple as just the 0 through 15. They're actually representing binary. It's just like a shorthand representation of it. So shortening an IPv6 address, I just have a random address, and this is the random address. The rules are that zeros can be cut down. So if it's a leading 0, like this right here, you can just omit them and it means the same thing. You can't do it if it's on the right. So if it was CF first and then 00, you can't omit those, but you can't omit them on one side. That's because it can get very confusing if you could omit them on either side, because you could have, something like this. Then you have CF, and you don't know if it's 00CF, CF00, etc. So you can only do it on that side. But I mean, this does help a lot. Instead of having to type all these zeros, you can just do a short, and it actually gets shorter. You can have consecutive O's can be displayed as this, once per address. And I'll explain that in the next slide because I found this pretty interesting. I didn't know this. Why only one shortening? So this is an example of one that's shortened where we shorten one side but not the other. Now the computer, when it reads this, it's going to expand that into 128-bit. So if you have two that are shortened, it's going to expand. I don't know if it'd be doing the first one or second, but when the computer reads it, it'll expand as many zeros to make it 128-bit. So if you have two that are both shortened, it's not going to know how many zeros are on which side. And if it just expands one side, then it won't have any room to expand the other. So this would be incorrect. Now I wrote it would expand the first one and not be able to on the second. I don't know that it would expand the first or the second. I know that the way the computer reads it, it expands one of them. And it is recommended to shorten the longer zero chain. So this is, I guess, not big. Well, this one technically is longer because it has these zeros involved too. But that's kind of, if there was 3 brackets of zeros on this side, it's probably better to shorten that one, just because then you will have less to write, obviously. But yeah, I found that interesting, this shortening, how the computer expands them. So the prefix notation identifies the subnet and the type of address. And this is like this expanded out. So the first bit right here, remember I said it's a hex, so it's representation of the binary. So if you take this hex and expand it out to binary, that is what it looks like. Understood? So these three hex little things expanded out. This one has 16 bits, this one has 16 bits, and this one has 8 bits. So it has a total of 40 bits. So that's just how this is written. I don't know if that makes sense to you. It is a little confusing at first. Take some time, really look at this, understand that, this is the first part. The second part is the DB8, then the 1200. And you're expanding it based off of this table, the hex representation, to binary, and then counting the bits there. So it is a little weird the first time you run into it. So global routing prefixes, these are some of the common ones. There's other that they're decided by, I forgot the entity name. I'll put that in one of them. But global unique unicast are these numbers. The local unicast are these. Unique local IPv6 addresses, those. The zeros are not important here, so this is a little confusing, but this is going to be on the front end of any address. This is how you're going to define them. So just for example, me saying the zeros aren't important here. This FF is the part that we care about. The only reason we have the 2 zeros here is, remember, we only abbreviate the zeros on the left side. So you have to keep these zeros, but FF, if we go back to this table, FF is binary 8 ones basically. So the address is going to start with FF. The zero is not going to start with FF00. It's just going to start with FF. It's a little confusing at first because you see FC00 and you're like, well, what's going on? The 0 is not the important part. Same thing here. FE8 is again, if you look at this, FE and then 8. That's how they came to that conclusion. So like I said, it's a little bit confusing at first. So global unicast address. So this is one of them. We're just going to go through this one, and it's going to try to make it as simple as possible. It's going to start with that, a 2000. I think I might have used a different example there actually, but the global routing prefix is this part, the 2000. So that's what it's going to start with. And then the rest of this is going to be the subnet ID. So whatever the difference is between the prefix and 64 is going to be the amount of space that the subnet ID allocates. Now the interface ID is always going to be 64. In IPv6, it's always a 64 subnet. I think you can do other subnets, but you don't need to because of how massive the space is. So if you remember IPv4, it was 32 bits. So just a 32-bit prefix in this has more bits than IPv4 had total. So the fact that we have so much space for the 64, for the IPv6, they pretty much just always use that. So there's no more subnet mask issues with IPv6. It's really just simplified things. Now, the interface ID, so the later part of it, so after the global routing prefix and the subnet ID, you have the interface ID, which is unique. And this, in this range, they use the EUI64 format. So the extended unique identifier format is used during the stateless address auto configuration or SLAC. You don't really need to know how this works exactly, but it is nice to know because like it says, it's auto configured. But if you just want to understand it, I'm going to explain it as briefly as I can where it makes sense. So the process is they take the MAC address, they insert FFFE in the middle of the MAC, then they flip the 7th bit of the MAC address, but it's done in binary. That always sounds confusing. And then they combine it with the link local prefix. So we're going to go through an example of this because I know like reading that just sounds like gibberish. Like, what are you talking about? So we're going to take this MAC address. This is the MAC address we have up here. And so the first byte is 02. So we convert this, the first byte, to binary. So the binary of 02, if we go all the way back to here, 02 is 6 zeros, 1 0. So that's 02 if you look at the hex and the binary, right? So back to this example, the 02 becomes 6 zeros, 1 0. And we're going to flip the 7th bit. So, did I write this wrong? Second from the left is 0. Somehow I did this completely wrong. Because that is definitely not. We should flip this one then. I might have wrote this wrong. I don't know why that's there. Okay, we're going to do this correctly. Whether or not I wrote it correctly. So let me see. That is the binary for this, and I flipped the 7th bit. So I really should be flipping it to this. So the modified should not be 03. The modified should be 00. So I messed up this example. I don't know if that makes sense. Now I'm wondering if I did it wrong. Somebody can fact check me if anybody watches this, but this is the process. It's behind the scenes. You don't personally do it. Slack does it behind the scenes. So yeah, you take the MAC address, insert that, flip the 7th bit. So yeah, this 02, the 7th bit is definitely a 1, and you flip it. I think I just wrote this wrong. You can see this stuff is a little bit confusing. But you flip the 7th bit, and then you convert it back to hex. And then you take that hex and insert it where you had it in the first place. So, again, all these examples are going to be wrong now because it's actually 03. So I'm just going to type that stuff out real quick. And so yeah, we flip the bit, then you split it down the middle, or at some, you can say after the 3rd byte, or in the middle. You add the FFEE. So all we did is add FFEE, and then you group it to the other format, the IPv6 format, where it's 16 block bits or 16-bit blocks. Then after that, you really just add it to this prefix from the beginning. Now this is the unabbreviated version of this, but let me go back, show you just the So this is just the link local. It's FE80. It just looks different when it's extended out like this. So they combine this with the MAC address that you've, and again, I have this number wrong, but you switch it to, oh, this changes the abbreviation too. This is actually kind of fun. So I switched this. So it's actually, there's another 0 that I can abbreviate. So this 3 actually just clears here. But yeah, this is what it does behind the scenes. You don't need to completely understand it, but just know that that's how Slack uses a UEI 64 format to give a device a what is the name of that again? That's how it gives the device the interface ID. So this all happens behind the scenes. You don't have to worry about it. And there's enough spaces where it's never really going to matter. So that's all I could do today. I'll get into the rest as soon as I can film again next and work on these PowerPoints. It's kind of a lot. I hope I helped you understand this. If I didn't, you can comment below. Maybe somebody else can help you in the comments, or I can personally respond to the comments to try to help you understand these concepts, just like how I'm trying to. So, hope you enjoyed. Like, comment, subscribe.